Factor theorem is quite a useful theorem. It's a theorem that helps us to find if there is if a number is a factor of a polynomial equation. In polynomial equations, if the number is a factor of a polynomial equation, that means it satisfies the equation. Satisfy the equation, it means that you will, if you substitute that solution into the equation, you should get an answer of 0. Because remember, when you factorize equations, polynomial equations, you make it equal to 0. Then you factorize it into multiple brackets, and all those brackets will give you equal to 0. Each one of those brackets is a solution. So by substituting the solution back into the equation, you should get an answer of a 0. And that's what we're going to do today. So we need to learn how we can achieve if it is a number as a factor. So that's what we call the factor theorem. So if we want to fully factorize this equation here. Now this equation here is to the power of 3. That means it has 3 factors. All the factors must adds up must multiply to positive 6. So we look for the factors of positive 6. So you can either get, you can multiply to 6, positive 6. It's either 1, 2, 3, and 6. All those factors of 6. Now, how can we check which one is a factor for that equation? Okay, so let's take one of them. So let's take, if x plus 1 is a factor, then x equal negative 1 is a solution. Alright? Now, x negative 1 is a solution. How do we know this factor is valid? Okay, to know if the vector is valid, you're going to substitute negative 1 back into the equation. If you get an answer of 0, that means x plus 1 is a factor. At this stage, we got an answer of 12. That means x plus 1 is not a factor. So let's try another one, x minus 1. So that means if x minus 1 is a factor, so look, I'm going by order, plus 1, now minus 1. So x minus 1 is a factor, then substitute x equal to 1, make sure this is equal to 0, rearrange, so x equal to 1, if I substitute that, I get a 0. Bingo! That means x minus 1 is a factor of this equation. So we've got one factor. Now we need to find the other two factors. So to find the other two factors, we all know the division or the long division in polynomial. We've studied that before. So to do that, we've already got this one as a factor. So if we divide the x to the power of 3 by x minus 1, we get one lower degree. So we get an answer of x plus x squared, which is a quadratic. So you can factorize this quadratic. It's easier to find the other two factors. And if you factorize this quadratic, you get x plus 3, x minus 2. So the 3 factors for this equation here is x minus 1, x plus 2, and x plus 3 and x minus 2. So now, and get the next one. Okay, the next questions is here. We're trying to use the factor theorem to completely factorize. Again, we will have to look for the first factor. There's 3 factors in here given, so we want that if we find one of them, we can use the long division to get into quadratic, then we can find the other 2. So the factors in here for 15 is 1, 3, and 5. Okay, so we're looking into the constant and we're writing the factors of 15. Now we will have to test those factors. So we'll try the negative 1 first. We get a 0. So yes, x minus 1 is a factor. Now we will use the long division. You can always use the long division. And then you get the quadratic, and then when you get the quadratic, you can factorize it, and that's what you get the answers in here. So you've got 3 over 4, you've got negative 5. So those are the 3 different factors, and then you can see if those factors are correct, which is correct anyway, and then you can, if you substitute the 0.75, you get a 0. If you substitute the -5, you get a 0 as well, and that's why those are 3 factors. Okay, so again, I'm just repeating how we found those 3 factors. The first one, we found it from the factors of 15. So we tried the first one and we got it right. That's why we got 0, so that's why we got this factor. Then use the long division, divide this equation by that, and then you will get a quadratic. Factorize that quadratic, which will be a harder quadratic. You factorize it, you got those 2 factors, okay? And that's where that will give you the other 3 factors anyway. All right. So this one here, that division, and then you fully factorize. You can see this is the quadratic. You factorize that quadratic, you get those 2, and then you got those 3 factors. I do prefer this method, to be honest, over the guess and check method. In this case, we only have 3 factors, so you can guess and check, but this method will give it's faster and there is no guess and check in it, except the first factor. So find the value of a such that x minus 3 is a factor of this. Now, because they told you x minus 3 is a factor, that means I will have first find the solution, which is x equal to 3. Now, if x equal to 3 and I know x minus 3 is a factor, so using the factor theorem means that if I substitute the 3 back into the equation, I should get a 0. And that's if you substitute, you get an equation which has a unknown, and you solve it and you get the value of a. And that's it for the factor theorem.